It's totally fine. Uh, it's totally fine. Just after 48 hours of the sessions getting over, we wrap it up and upload the recording plus the session deck on the exact same page from where you're registered. I'll also paste the session links here once again. So it's fine if you cannot attend it at the very moment. The recordings would be available on the page at any point from any part of the world. Uh, Also, we please feel free to leverage the chat session in case you have any questions to put on. We have experts who can answer that real time during the session. Um, and yes, we also have a dedicated 15-minute time towards the end for the question and answer. So if you feel that unmuting your mic and interacting would be a better space for you, feel free to do that as well. Um, that's more about it from my side. Please, let's keep it an interactive session, and I hand it over to the speakers for today. Over to you, Ramakrishna.
Thank you, Sumani. Hello, everyone. Thank you all for joining. A very warm welcome to all of you. I am Pawan Rathore. I have been working as a senior technical account manager for UiPath. It has been more than 12 years of journey for me, and more than 9 years I have been with UiPath. In this journey, I have been looking forward towards large scale enterprise customers in their automation journey, wherein I help them to grow, adopt in their automation journey, and reach to a point where they can really realize certain values from the automation, right? I keep on advising the customer on their COE excellence, implementations, solution design, etc. So this is all from me. Thanks a lot for joining in. And with that, I'm going to hand over to Ram to further continue with the session. Ram, over to you.
Thank you, Pawan. Thanks a lot. So, team, myself Ramakrishna Kadia, and I'm having around 16 years of experience into the IT field, and I have been working with UiPath for around 3 years as a technical account manager, and I closely work with my customers uh, and their COE team members, infra team, stakeholders to get the better value of their the automation program, right? So today, as you already know, we are going to deep dive into the UiPath Automation Suite as a topic, and it is scheduled for 3 different sessions. And today, this is the first session. All right. So let's get started with it. So feel free to add Pawan and myself on the LinkedIn, and we'll get in touch on LinkedIn, right? So in this particular session, we will talk around UiPath Automation Suite platform, its architecture, and context revolving around Automation Suite. Okay, so to start with agenda. Okay, so as you can see, the first one is Kubernetes versus the traditional infrastructure, which will be followed by overview of the Kubernetes cluster architecture, and then we will have a deep dive into Kubernetes components, and at the end of the Kubernetes discussion, we will have a networking fundamentals, and then the discussion on automation suite infra will start, which will be followed by the fabric and UiPath service components, and at the end we will have multi-node HAA, which is high availability add-on architecture walkthrough, right? So let's move to next slide with Kubernetes versus traditional infrastructure. So before we discuss about Kubernetes, right, we let us understand a little bit about container, right? So what is software container? So software container is a standardized executable package of software that bundles an application code together with all the files, libraries, and dependency within it, right? So these are lightweight, portable, and the consistent across different computing environments, right? So be it on test server, production server, or cloud environment, right? And this consistency is achieved by packaging the application and its environment together. So certain characteristics like isolations, right? So which is container run in isolation from the host operating system, and other containers uh, and each container has its own file system, CPU, memory, and the process space. If we talk about the portability characteristics, so since the application is packaged with its entire environment, it can be easily moved and run consistently on any machine that has container runtime like Docker or Container D. In Automation Suite, it is built on Container D. And the efficiency. The containers share the host system kernel, which makes them much lighter and faster to boot than the full virtual machine boot, right? So now let us come back to the Kubernetes versus the traditional infrastructure. So to start with the architecture, right? So in Kubernetes, we have the container-based orchestration, whereas in traditional infrastructure, we have physical or the virtual servers, right? If we talk about the scalability, so horizontal scaling is of container is available in Kubernetes, meaning that we can scale up and scale down the containers. Where the same is available in traditional infrastructure as the manual scaling, right? So manual efforts has to be done for adding or removing the servers or the VMs. And infrastructure provisioning, so dynamic provisioning of resources based on the demand. So like as you already know that in the holiday season, the festive season, there will be some the surge on the shopping websites, right? So the resources should be increased, right? So in that case, if these particular sites are created on the Kubernetes, automatically the resources will be added based on the demand. And once the holiday season will go off, the resources will be revoked. So this is something which is not available in traditional infrastructure because it is static provisioning. Next up is the fault tolerance. So in Kubernetes, the built-in container replication and failover is available. So replicas can be created based on the configuration, and if any pod is crashes or it is terminated, right, it will be respawned automatically based on the configuration created. In traditional infrastructure, same has been achieved through additional configuration or the third-party tools. If we talk about the environment consistency, right? So in Kubernetes, we have the uniform environment across dev, test, production. So it eliminates the issue which mainly developers are facing, right? It works on my machine or the development environment, but not in test or production, right? In traditional infra, there are some or other differences in dev, test, and production environments. And next up is the portability. So the high portability is available between the cloud providers and on-prem, whereas a traditional infra is tied to specific cloud or data center in the infrastructure. Okay, so next up we will discuss about the overview of the Kubernetes cluster architecture, right? So the key components of Kubernetes cluster architecture is a master node, worker node. Behind the scene, the networking and storage is there, and pods and services are also there. Okay, so pods is smallest deployable units in Kubernetes, right, which runs the container, and service defines the logical set of pods and policy to access them, right? So as you can see in the diagram, right? So uh, at top, any user um, will use the GUI or CLI to access or to send the command, right? To access the Kubernetes cluster. So these command will be received by the API server component, which is available in master node, right? And based on the command, it will then forward its request to the worker node, which is available right below into the yellow boxes, right? And it will the it will forward the request to designated pod and container, and through the service the response will be again sent through API servers, and then it will be sent back to the the admin UI or to the CLI. This is very high level architecture. We will see the brief about all these particular components like controller manager, scheduler, etcd, API server in next few slides. Okay, so let us talk about the master node. So master node in Kubernetes architecture is also known as a control plane, right? So let us talk about the API server, right? So it is also known as Kube API server, and it exposes the Kubernetes API and act as a central management interface for the cluster, right? And it provides a REST interface to interact with the cluster, and it validates the processes and the API request, right? And it is the entry point for all the communication, and it includes from external clients and internal services. Next is scheduler. It is also known as kube scheduler, and it decides which node should run on a particular node based on the resource availability and constraints. Right. So based on the resource availability, the free, if any node is free and any pod has to be deployed, then the that particular node which is free, which whoever is the most free resources will have that pod deployed on it, right? Next up is controller manager, which is kube controller manager. So in Kubernetes cluster, we have the terminology like desired state and the actual state. So desired state is something which we want our Kubernetes cluster to be in actually to solve our purpose, right? Based on our application requirement, right? So and actual state is something which has to be in line with the desired state, right? So the job of control manager is to maintain the desired state of the cluster by managing controllers that ensure the current state matches the desired state. Okay, so there are multiple type of controller replica set manager responsible for managing the replicas, a deployment controller to manage the deployments, and node controller, right, which manages the nodes as well as it checks the health check of the nodes. The next component it is the etcd, right? So it is a distributed key value store which stores the cluster state and configuration data. It also stores the desired state of the Kubernetes cluster, right? So through Kubernetes cluster, control manager and scheduler will be able to understand what is the expected desired state, and comparing it with the current state, it will take the relevant action to keep the cluster healthy and in align with the desired state. Okay. Next up, we have the worker node. Okay. So there are three components mainly, which is to start with kubelet, right? So kubelet ensures the containers are running in pods on the worker node, right? And it acts as the agent that, right? So this kubelet will run on each and every node, it ensures that the containers are running in the desired state, which is available into the desired state data is available into the etcd, right? And uh, kubelet will communicate with the API server to receive the request, right? To create, terminate, or monitor the pods. Okay. Next component is kube proxy, right? So it manages the network traffic and load balancing within the node. So ultimately, it maintains the network rules to allow communication between pods, services, and external networks, and also perform the load balancing for services. Next up is the container runtime, right? So container runtime is required to run the containers in the pods, right? So there are multiple type of containers, as we mentioned earlier, like Dockers and Container D, and automation suite is it runs on Container D. Okay, so now we will discuss about the various components as we discussed, right? So um, first component is pod. So as you can see in the diagram, the one in the worker node 1 and worker node 2, we have two pink boxes, which is pod 1, pod 2, and pod 3. So that is pod, right? So a pod is the smallest deployable units in the Kubernetes, and it can host one or more containers which will share the same network space, IP address, and storage. So every time a pod is created, it will have its IP address, and once it is recreated or it is crashed and it is created again, then the IP address will change, right? And pods are ephemeral and can be terminated or rescheduled by Kubernetes. Okay. Now, next is secrets. Okay, so secrets are used to store and manage the sensitive information, right? So we can keep the sensitive data out of configuration files and out of code, right? And usually these secrets are kept in base 64 encoded format. Ultimately this is not the encrypted format, it is the encoded format, meaning that it can be decoded. Also, to keep our the cluster secure and the secret secure, we need to have the secure access to the cluster. So no one should have unauthorized access to the cluster. And by default, these secrets are stored into the etcd database, uh, and it will store as a plain text, but we can enable encryption to protect these secrets. And the example of these secrets are, it can be the database username, database password, or API key and secrets. So now, as you can see in the right section, there is a snapshot of secrets YML file. So first one is the API version, and then kind. Kind is written as a secrets, which informs that this particular configuration is secret. And under metadata, you have name of that secret as a UiPath -secret, and under data, you will have the various key value pairs of different secrets that you want to store, like DB username, DB password, and so on. Okay. Next is config maps. So config maps is used to store the non-sensitive configuration data. Again, it is in key value pair, and it is stored into the etcd data store. And by using config map, we can separate the application configuration from the code, and this will make the it is easier for the update any code, right? Like say for example, if you want to move from one environment to another environment, right? So we just need to change the config map, right? We don't need to touch the code, right? So that way config map comes handy. So we do not need to deploy or modify anything. Apart from that, these config maps can store the data in various way, like key value pair, configuration files, or even the directories of the configuration files. So some examples of the config maps are the database host name, database port, API endpoint, and so on. So in right section, if you can see, there is a API version that is basic, then kind. So this kind will again let the cluster know that this is the config map configuration, right? With name as my config, and uh, the, under data you can see database URL, app environment, and log level. These are the various configs along with its data in key value pair. Okay. Okay, so next up is deployment. So Kubernetes deployments manage the deployments and scaling of the applications, and it allows to declare the desired state of application, and Kubernetes will ensure that the actual state matches by automatically handling rollout, scaling, and updates. Right. So if we talk about the rolling updates and rollbacks, so ultimately, deployment support rolling updates, allowing us to update applications without downtime. If anything goes wrong, Kubernetes can uh, automatically roll back to the previous stable version to ensure high availability and minimize disruptions. Uh, Next characteristic is replica management, right? So deployment maintains a specified number of replica pods to ensure our application is always running with the desired number of pods, providing fault tolerance and high availability. So in a right section, if you can see, right, in a snapshot, we have the replicas, right, under spec on line number 6, right? So it is currently set as 1. So it will, by this configuration, we will have the one pod of this particular, the deployment. If we set that replica as 2, then we will have the number of pods will be generated as 2 for our for that particular container. Okay. Now, next feature is self-healing. So if any um, pod is crashing, right? Any deployment, or terminated, right? Then Kubernetes will automatically create a new pod to replace it. This ensure our application remains running as specified without manual intervention, right? And the last one is the version control and history. So deployments keep the track of historical revisions and allows us to easily roll back to previous versions of the applications, providing better version control and recovery from the failed deployments. Right now, in uh, in the snapshot at right side, you can see, right, in second line, kind is deployment. It is similar to config map and secret. This is, since it is deployment, we should mention it as a deployment. The deployment name is nginx deployment, right? And if we look at the specification on 14th 15th line, right? So containers is nginx and image will be nginx colon latest. So it will create the container with the latest version of the nginx with uh, container port configured as 80. So it will be accessed from the port number 80, right? Okay. So next up is the Kubernetes networking fundamental, right? So there are many ways by which the communication will happen, right? So first one is the pod to pod communication. So Kubernetes follows a flat network model. It means that the pod gets an IP address that is reachable by every other pod across all nodes in the clusters. And uh, when one pod needs to communicate with another pod, it simply makes a request to the IP address of the targeted pod. And Kubernetes takes care of the routing between the pods. So if you can see in the right top section, right, we have one node 1, right? And uh, within node 1, we have pod 1 and pod 2, right? In pod 1, we have container 1 and container 2. So container 1 and container 2 can directly communicate through localhost since they are part of a common pod. But if we want to have communication between pod 1 to pod 2, right? So at that particular time, the Ethernet interface of ETH0 of pod 1 and pod 2 comes into the picture through the root network namespace using the virtual Ethernet, right? That is something which is provided by the Kubernetes. Okay. Next one is pod to service communication. All right. So in Kubernetes, a service is an abstraction that allows us to expose a set of pods to other components or external traffic. Pods can, come and go, and service provide a stable interface for the connection to those particular pods. And this is something which is achievable through cluster IP, right? So cluster IP is nothing but a service type which gets an internal IP address, which is used to access the ports behind the service from within the cluster. And pods can make request to this service IP to access the set of pods. So say for example, if you have a set of web server ports behind a service called nginx service, then other pods can communicate with nginx service using that uh, service cluster IP to reach the web servers, regardless of how the individual pods are scheduled or restarted, right? And Kubernetes automatically provide the DNS resolution for the services. So instead of using the services IP, you can also use the service name to access the service. Okay. Now, next is service to pod communication. So when a request is made to service, Kubernetes need to direct that request to one of the pods behind the service. This is done via kube proxy, right? Uh, which is the component of the worker node, and this is which is component of the every node in the cluster, right? So proxy manages the communication between the services and the backend ports. It does this through various methods like IP tables or IPVs to ensure the traffic is properly routed to the appropriate pod, even if the pod is on the different node, right? So you can see the pod to service and service to pod example in the the right bottom section, right? uh, now we will discuss about the service types, right? So the first one is the cluster IP. So this is the default service type, and this is only accessible within the cluster, which we have already discussed in the pod to service communication. Then next one is the node port. So this exposes the service on specific port on all the nodes. This allows external traffic to reach the service through any node's IP at the given port. Okay. Next step is the load balancer. So load balancer creates an external load balancer to distribute the traffic across multiple nodes and pods. This is usually the most efficient way to expose services to the outside world, but it requires the cloud provider support. Next is ingress. So this is more advanced way to expose the service, where traffic is routed to the correct service based on the HTTP request URL or other properties. It is typically used for routing HTTP or the HTTPS traffic. So in automation suite terminology, say for example, there are multiple DNS endpoint we have in automation suite. Say for example, ALM.FQDN or the uh, monitoring.fqdn. So uh, once we hit those particular URLs, firstly it will go through ingress, and through ingress it will then go to the Kubernetes cluster. Based on configuration, it will hit the the underlying service to get the response. So this is how at a very high level the Kubernetes networking actually works. So yeah, so uh, this is something which is encompasses the fundamentals of the Kubernetes. Uh, Next, Pawan will take care of the further slides with regards to the automation suite architecture and all. So over to you, Pawan.
Thank you, RK. That was very insightful. I will share my screen. Guys, do let me know once you are able to see. Okay, you guys able to see me? Like, RK, can you confirm?
Yes, I can.
And it is the routing slide, right?
Yeah.
Okay, thank you. So these were, thank you, RK, with the fundamentals of Kubernetes, how the networking works, what are the pods, and how the communication between the cluster works. Now we will move on to the actual platform automation suite, like how the communication is working, how the setup is being done, what will be the overall design, and how the communication and the workflow happens within an automation suite cluster or an automation suite. If I have to take an example, say that when you open automation suite platform or an automation cloud platform, how would you access it via browser, and then how it reaches to the load balancer, and then once it reaches to the load balancer, how the request has been segregated across the multiple services, how does it get routed, how does it get the response back. So client could be anything here. I'm referring to client as an browser, robots, action center, or any other tasks. So any action that you perform on the GUI of the platform, that particular action can act as a single request, and every single request passes on with a similar mechanism as to what all actions should be performed, right? So like if you want to set up, right, how would the overall design that would look like? So I have just taken this, a very simple example and design diagram so that you can understand, right? So we have a DNS. So first, what we will do is we will configure a DNS wherein we can say a name could be automation platform.xyz.com. So this will be your access URL from using which you can access the URL. Against which, what you will do is you will define the certain set of IP of the load balancer. So what would happen is any client, say that from browser, whenever you hit automation platform.xyz.com URL, using the DNS, that would resolve into the load balancer IP. And once it resolves into the load balancer IP, what would happen is the load balancer gets configured with certain set of server nodes. And we will get into detail of each of these server nodes as to what components are there. So the traffic would get routed on any one of these server nodes. The point to note here is the traffic does not get routed to the agent nodes, and neither we do configure the agent nodes at the load balancer level. So for a request that resolves DNS to a load balancer, and load balancer is gonna redirect the traffic to any of the server nodes. So all the server nodes could be configured. Currently, as you see in our cluster, what is happening is we are having 3 server nodes and 2 agent nodes. Agent nodes are also known as the worker nodes, and server nodes are the control plane nodes, as RK just mentioned. Once the traffic gets routed to the server nodes, uh, there is no direct connection, if you observe, from the load balancer to the agent nodes. So the traffic is never going to the agent nodes, which means the traffic always gets routed from the server nodes to the internal agent nodes. Basically, agent nodes are the worker nodes. If I have to take an example, you have a task mining node. You have a DU node, which is tainted with GPU. These are the specific worker nodes wherein certain pods of services are being deployed, and these worker nodes are responsible of executing on your request, processing your request, and sending the response back to the server nodes and back again at the load balancer with the DNS, and then the response reaches back to the client. Again, it could be a robot, browser, or anything else, or any third-party application that you configure via APIs, certain connectors or adapters that you may build on. Now, all the communication from the server nodes and agent nodes can directly happen to the SQL Server. I will take an example. Say that if you're creating a queue item, as soon as you hit automation platform, what would happen is the request will reach to the load balancer. From the load balancer, the request gets resolved at the server node. The request gets identified, stating that this is an orchestrated request, and it would forward the request to a particular agent node wherein orchestrator pods are being hosted. Those pods are going to process the request from the server side. Once the request is processed, is going to send the response back to the client. So this is the SQL Server. This is the basic overall design, right? And currently, if you see in this design, we have 3 server nodes, 2 agent nodes, which means this is a 5-node cluster. Now, you can increase on the number of server nodes, and you can increase on the number of agent nodes as well. When it comes to the server nodes, the point to consider is it has to be an odd value. Like you can have 3, you can have 5, you can have 7, you can have 9, etc. And agent nodes, you can have n number of them. Fine. So this would be the basic design, and I will go to the next slide. So what are the basic components that are majoritarily needed? If I go to the bottom section, we will start off with the operating system. So to install Automation Suite platform, we support multiple platforms like EKS, AKS, but currently for these sessions, we are assuming that we will be working with the Linux system. So we will be installing embedded automation suites in upcoming sessions. So the operating system, we can assume here that for these sessions is Linux. The supported Linux versions range from 8.8, 8.9 to 9.2, 3, 4, like that. And as soon as the latest Linux patch comes, I think we do support it in some time frame. Right, and the components external to the Linux or the server machines would be, so if we are creating a cluster, say that this is the operating system, we would need, say that 5-node cluster, taking back the other example, say that we are planning to create a 5-node cluster. So we would need 5 Linux machines here, 5 servers, depending upon the requirements or the capacity planning that we do, we'll come to that. We can choose on the number of CPUs that might be needed, the RAM that might be needed, etc., with the other prerequisites. Now, what could be the other prerequisite is, one is you can opt for an external object store. When I say external object store, the data, whatever is being generated by the cluster, right, that gets stored, like you are uploading NuGet packages, you are uploading a number of documents, right? So there are two choices to it. Either you can store these documents, items, service data, or the cluster data into certain S3 buckets, and we do support Amazon S3, we do support Azure Blob Storage, and any of the standard S3 buckets that have been provided by the majority of third-party vendors. So that is one option. So that is configurable. While we are configuring automation suite cluster, we will see and have a look as to how we can go ahead and configure S3 buckets within the platform. There is also a choice wherein you can opt for an in-cluster storage. So in-cluster storage generally remains on your server nodes. It doesn't reside on the agent nodes. So say that if we have to consider the data redundancy here. Say that if you're having 2 TB of data, so basically 2 TB storage might be needed on each of the server nodes, because we do maintain the high availability, so that data gets residing into any given point of time, it resides at multiple places, so that with the failure of any one server, the data doesn't get lost, and you always have access to the data. So this is majoritarily in the term of Azure Blob Storage and external storage that would be needed. The next I would go to is the Microsoft SQL Server. Now, we can go ahead and deploy the entire automation suite platform with a single Microsoft SQL Server, depending upon the usability. But if you are planning to add process mining as an application within the automation suite cluster as well, then probably it is recommended that you go ahead with 2 database instances, 2 server instances of the SQL. And OCI compliant registry, there are 2 ways to do it. One is, right, you can host the registry within the cluster itself. So basically, if you are having a server node, particular server node, you can create a local temp Docker registry wherein you can fetch all the images or extract all the images that are needed for the installation, or any image for the services upgrades that is needed. You can go ahead, extract those images, push it into this Docker registry, which can be hosted locally and installed locally, which we'll be doing practically as well. I will be showing in detail as to how you can go ahead and create a Docker registry and push certain images to it. So once the registry is created, you host all the images. It acts as a repo for all the services images within it. Right now, later point of time, if you need to upgrade certain services, you can push a new image and then upgrade the particular service, or vice versa can also happen. If you want to downgrade from a new service to an older registry patch, you can do that as well. So both ways it is possible. So these are majoritarily the storage component and the SQL Server and the object store components that are needed for the installation. Right. So operating system is Linux. So once the operating system is installed, we use RKE service, right? RKE service acts as a control plane bundle. As RK was showing, right? RKE service has 3 components, and it is responsible for etcd, controller manager, kube server APIs. So RK service, what it will do is it will act as a control plane. Any request that comes in, what would happen is it will go through the RK and then Istio. Now RK has three components. I'm gonna move forward if I have to decide this. So RK generally holds the control plane, which is etcd, the functions of which RK kind of explained in very detailed, and control manager and kube server APIs. So etcd is a single point of all the configs true, which is like up to date, and any config it keeps as an stored with it, acts as a database. So anything that is needed, any IP, pod address, key value pair, location, secrets, all this is updated within the etcd. Right? Kube server API acts as an whatever the communication that happens between the clusters, right? The kube server API is responsible. It acts as in front door to the control plane. So basically, whenever a request comes, kube server, it will land up to the kube's API server, and using the etcd controller and schedulers, it is gonna make the subsequent queries to the control planes. Now, there are furthermore components to this control plane addition. I will talk about Istio, Argo CD, and Registry. Registry, as I have already discussed, right? It holds all the images which are corresponding to the Microsoft, which are corresponding to the Automation Suite platform. Now, as you know, right, within the Automation Suite platform, if I go back, at the top, we have listed UiPath products. If you see document understanding, insights, orchestrated task mining, test manager, action center. So all the majority products that are bundled here with the platform would be listed. Right? You have a choice whether you want to install particular set of applications or you want to install entire suite of applications. You can decide at runtime, you can decide at installation, and post or before installation, you should be able to decide whether to add which application. That would significantly help you guys with the capacity planning. Say that certain organizations would like to start off small, and they would like to use orchestrated NDU, right? So at an initial state, you can opt for a smaller cluster wherein you have orchestrator and document understanding. But as your journey grows within the automation platform, what you can do is you can keep on adding services one by one subsequently and increasing the size of the cluster as like once orchestrator and document understanding is done, you can start off with action center, then AI center or test manager, automation ops, etc., etc. There is always there is also a provision that you can remove a particular service once it has been installed. Say that uh, I don't need to have apps. What you can do is you can go ahead and remove it from the configurations. So that option is already available. Coming back, right? So this is an RK. The request comes here. This act as an then the request goes to the Istio manager. Istio is an ingress gateway, as Ram discussed, right? It acts as an ingress gateway. What it does, it keeps the list of all the IPs, pods, containers, and it identifies the request as to where it should go, basically. So if I assume, right, whenever a robot is connected to the platform or the orchestrator, so a request is coming, and since this is the entire platform with all the services, right? The Istio knows as to the request should go to which particular microservice and which particular microservice should process it. Then it also gets the response back and then transfers back to the client itself. So again, I will take an example of document understanding. Say that you pushed certain documents, right? So it will come via RKE, again, following the same loop. Load balancer then goes to the server nodes. So these are the internal parts of the server nodes like RKE, Istio, Cert Manager, and OPA. So Istio will decide on the particular request and send to document understanding. This bifurcation is very necessary. Why? Because any request, any client can go to any of the services, and we don't want that. Hence, Istio is being used to manage the traffic and where the request should get placed, or which microservice should handle that particular request. So Istio handles those kind of requests, then cert manager. Now the communication between the microservices of automation suite platform. If I consider document understanding as a one microservice and the orchestrator and another microservice, right? There is always a communication between document understanding and orchestrator, or orchestrator or insights or task finding, right? So to keep the platform as in very secure, right? The communication doesn't happen directly. What happens is if document understanding has to reach to the orchestrator to update certain queue items or certain status, right? Or mark certain items, or I would say go to action center. So what would happen is the request gets back to the Istio gateway. Within the Istio gateway, the request still gets analyzed and then gets moved back for processing on the orchestrator pods or on the insights pod. Now, these microservices, you can, for the time being, you can assume that they are running as pods, and these pods could be on any of the agent nodes or server nodes, right? So Istio correctly should identify as to on which particular need, which particular node orchestrator pods are running, are they available, and if they are available, it should move forward the request, right? And this has been handled by the RKA control plane as well. So it continuously monitors the entire cluster. So if a pod is up, you can assume that the service is up. Say that orchestrator pod 1, 2, 3. There are 3 nodes, right? And if I have to take, say that 2 pods from 2 nodes are down and orchestrator is running only on one particular node. So RKA maintains that particular status, and Istio takes the responsibility of redirecting the traffic to the working nodes only. It doesn't transfer the load to the faulty nodes or where the pods are not working. Plus, RK is also responsible in case there is a failure. It will always try to respin the pod, restart the pod, or or spin it on a different node. Right? It does have certain limits on the timeout and the errors. Like once it exhausts all the retries to successfully run a pod, then it will exhaust, and then probably it may see some errors which could be looked upon. Now, cert manager, now this communication within the cluster happens internally, right? And this internal communication must be secure in some way. So we are using one of the components known as the certificate manager, wherein certificate manager takes the responsibility of creating certain SSL certificates which are required for microservice to microservice communication. In our instance, any of these microservices like Action Center apps, Automation Hub, Automation Ops. So what happens is every 60 days, it creates a new certificate, 60 days, 90 days, depending upon the frequency, it creates a new certificate and rotates. So the communication within the cluster always happens on HTTPS, SSL, MTLS, and the communication that has been originated from the client, whether it be robot, browser, or anything, that is also on HTTPS. So the entire communication, end-to-end communication, is being encrypted via TLS 1.2 and SSL. And so furthermore, monitoring and backup, right? So if we go to like now, this is a cluster, right? These are the core components, and we certainly need a lot of monitoring on this cluster as to which components are functioning appropriately and which are not. So Alert Manager, Prometheus, and Grafana are being bundled within the automation suite, and with the automation suite installation, these components by default do get installed. So once the installation is completed, you will have certain advanced automated alerts and the performance monitoring systems in place as soon as the installation gets completed. This you get by default within the automation suite cluster as well. Now, Argo CD is a kind of a GUI based management platform wherein you can go ahead and monitor your cluster. You can manually, if you want to make certain enhancements or changes towards the cluster or the pods or the settings on the config maps, you should be able to do it by Argo CD. You can monitor the health of the cluster as well via Argo CD. If there is a need and there is a challenge, if you cannot log in into the actual server machines, you can try to restart the deployments for the multiple services, and you can try to reconfigure certain connection strings, etc., etc. So it kind of acts as a management portal for the entire cluster, which is very much GUI based, and you can use it. Fluentd, I think, since there are a lot of components, there are a lot of logs that are being generated. So Fluentd is responsible for managing all the logs that are being generated by the cluster. These logs could be targeted to a third-party target-based system as well. You can take it to Kibana, Splunk, or any of the third-party tools, right? And these logs could be exported there. Valero, like since we are setting up this large cluster, right? And even though there are a lot of residencies built in, there are chances we want to be very much secure so that we never lose our data, we never lose our cluster, and it is always up and running. So Valero is one of the components wherein it provides you assistance with backing up the entire cluster. You can back up the configs, right? And once you back up those configs using that particular NFS backups, you can restore the entire cluster if something goes wrong for a worst case scenarios. Right, and then it is a Redis, right? This Redis is being a standard we use with our orchestrator standalone environments as well. This is an persistent database, right? And which helps in caching the keys and the details around it, which helps us to faster access the GUI, the session management, and access provisions, right? So these are the major shared capabilities, right? So as we have already discussed, right, RKE2 provides an orchestration layer for all the microservices, right? As we have suggested here, if you go back and look at this, it is an orchestration. RKE acts as an orchestration layer, right? So the entire UiPath platform microservices are behind multiple walls, like RKE2, Istio, etc. Now, if RK2 is not working, this is a service, right? And we are using this as an orchestration for our microservices. So if this is not working, I think your cluster will be completely down because this is the entry point to any service which is running within UiPath. So this is a major component, and the same goes with Istio gateway as well. So this acts as an ingress. If there are certain issues or challenges within the Istio ingress gateway, the request won't get forwarded to any of the for example, or request, and the response will not be. So these are very, I would say, key components that are being used here, and failure of any of these server components would result in failure of the application, and the services might not be usable or available at that particular point of time. So if I have to say, cache, monitoring, backup, network and security, Kubernetes, all this part is majoritarily for the server nodes, which acts as a control plane, as a baseline design to access the microservices of the UiPath. Any questions? Okay. So as discussed, right, Istio acts as a traffic management platform, right? And it enforces MTLS between the microservices. So basically the communication between each of these services is being encrypted and secured. Now, the benefit of having Istio as a gateway, right? Any service, any third party service or any other service who gets the IP address or the service details of any of these, say that assuming some third party gets an orchestrator like details and they want to go ahead and try to access it. They won't be able to, because the traffic is being majorly routed from the Istio gateway. So it is pretty much secure. It maintains the security and the sanity of the system. Argo City, as we discussed, right? This is a GUI-based platform management, like automation suite cluster management platform, wherein it allows you to create certain deployments, to scale up the pods. You can go ahead and also uh, force restart certain services or any of the services. You can restart the deployments, you can scale up or scale down. And in reference to the scale up, so basically each of the services have certain default number of pods. Say that uh, orchestrator, right? As soon as you start orchestrator, it would try to start maybe 2 or 3 pods on certain nodes, agent node or server node. So what would happen is, as soon as you grow within your automation journey, right? Say that today you are having 10 bots which are being processed by one particular pod. Tomorrow, what will happen is you might have 100 bots, and the load is going to grow on the system. So RKE services take care of that scaling as well, so that as soon as the load grows, RKE services would be able to identify whether I need to scale this up, right? So that as soon as the load is more, it might scale up the number of pods from 2 to 4, 4 to 6, 6 to 8, or 10, 20, like this, so that you never have face any challenges with the performance or scaling up your infra. It automatically does it on your behalf. You don't have to maintain it, right? And similar goes with the other applications as well. Depending upon a fact whether you have a sufficient capacity within your server machines so that they're able to scale up the pods. So if the capacity is there, I think RKE2 in performance perspective, it is going to automatically scale up the pods so that there is no challenges or issues with the performance of the platform. And I took Orchestrator as an example. The similar thing goes with a document understanding, action center, data service, and other microservices. Though at some places it might not be automatic, you should be able to manually scale up the deployments. When I say scale up the deployments from deployment number, say that number of replicas is 2, you can make it that 4. So which will go ahead and deploy a number of 4 pods on any of the nodes, basically where it will be running. So either it is optional, manual, or you can go ahead and increase and scale up the pods wherein the performance is not impacted. You are able to take more and more loads, right? And Orchestrator, it is automatic scale up. So this is pretty much it. I will cover, as I already discussed, right? Registry. We are able to create a secure Docker registry bundled within the platform, and we should be able to install a simple Docker registry where it will host all the images, registry images from UiPath, and that would act as a centralized point to give the images for the installation and the required updates, etc. So I think this was majoritarily for the first session. Now, I understand this session might be more of theoretical, but next section would be very much critical, because instead of theory, we will go in detail and hands-on practice, look at each of these components on the server machines. We will try to install automation suite on call, bring it live, and show you what all different components are on the GUI basis. So on the second session agenda, so we will go ahead with automation suite single node installation. I would show you live with the packages as to how you can go ahead and install it, what are the prerequisites, what are the deployments, and how you can do the capacity planning for a single node, right? And post the single node installation, we will also jump off to the certain prerequisites of like installing the temp Docker registry and how it is going to host the images, then Kubernetes infra layer and the agents. So if I have to go back to the initial diagram, so we will be installing the infra layer and the service layer. So UiPath products is the service layer, you can assume, and the shared capabilities and infrastructure part, that would be kind of a infra layer. So we will install both of them, and we will try to connect it across. We will make certain DNS setups as well, as discussed, like how you can go ahead and configure the load balancer, what all server nodes should be configured, how you can go into those configurations. We will look live. We will do this live on call, and we will try to kick off the installation for HA after completing the single node installation. This we will try to cover up in the next session. That session will be very important because it will be live and we will be covering a lot of details in that sessions. So thank you guys. Thank you for taking time today and connecting with us. I hope this is beneficial to you. And
Okay, thanks, Pawan. That was very insightful. There are some question in comment box if we can help with.
okay. So guys, feel free to post your questions. I would be very happy to answer this.
The first one is documentation shows that LB routes to agent nodes.
Yeah, it can route to agent nodes. We wanted to keep it simple.
And another one is
This,
regarding EKS.
yep.
So
I'm not able to see the diagram. 1 second. Well, you can do that in an not an ideal scenario, basically, but you can do that, Samuel. Hello, can you hear me, guys?
yes, of course.
Samuel, you are able to unmute yourself, maybe? No, okay.
Yeah.
So, yeah, Samuel, we can hear you. You wanted to say something? I think you had some queries around that.
Yeah, I'm just asking, is there a reason why you say that the load balancer will only route to server nodes?
Because the Istio gateway control plane and RKA services are being hosted on the server nodes, which are responsible of rerouting the traffic. I needed to check this diagram, whether it is like, I am not able to see your diagram, Samuel. I will clarify that, like if you can send me that across. RK, are you able to download his diagram?
I just got this from the official documentation,
Yep,
right? Just
yep.
wondering
Okay.
why you are recommending
In
something different from
certain,
the
no,
documentation.
no. I think it goes both ways. That's what I'm trying to say. So as an overall design, you can try to do that as well. So, but what we try to do is, uh, we try to keep server nodes as in 3 and try to send the traffic to those server nodes. But if you can go ahead and configure agent nodes, that should be dual as well. I think we have done it in past and it works. There is no issues.
Yeah, I will share the diagram in Slack. Pawan. I think we lost Pawan. Pawan, are you there? Yeah, I think he has rejoined. Yeah, Pawan.
Sorry, I think I got disconnected. Huh?
Yeah,
Was that the case? Okay, I wasn't able to hear you guys. So
yeah,
where did I disconnect, Samuel? Are you there still?
yeah. He's there, and I've shared you that image in Slack.
Okay, that's fine. So Samuel, I think it's recommended, like, but you can go ahead and configure both. 25.10 would be releasing in couple of months. I think it should be very near. I released it. Fingers crossed, as soon as it gets released, I think we will update our official documentations. Yes.
Okay. And another question is this architecture same for the EKS implementation too, right? So I think it is overall same, right? The basic architecture is same. The
I
deployment
think
type is different.
I think this session is majority for embedded, and we can definitely refer to for the exact, like, for different components like EKS, AKS, and other details. I think it would be best if you can go ahead and refer the official documentations, because certain things keep on changing, and that would benefit actually.
Yeah,
Yeah, thank you, Pawan. Yeah.
I have provided the link to the documentation if that can
Yeah.
help Venu.
Yep. Okay, I think how does Argo CD GitHub helps in Kubernetes deployments? I think we are providing, like, majority the deployments that were done, like, internally, we are using RKS and services only. Argo CD is acting as a delivery system for us. So it also provides us the GUI interface, like, where you can go ahead and try to perform your n number of operations that you would like to. Okay. Meanwhile, like, if I have to give an example, right? See, Argo CD will give you the exact current desired state if you go to the GUI for all the services, the state of the pods. You can check the drift as well, and then you can try to sync the entire cluster as well. Say that certain uh, application or microservices are not being deployed and are in an error state, right? What you can do is you can go back and try to resync it, restart the deployments, etc., etc. So it acts as a kind of a Git delivery system, right? Wherein you can go ahead and deploy the new services again and restart the services, and it completely pulls up the image and deploys you as in fresh. Does that answer? Question?
In that case, over to you, Sohani.
Perfect. I think there are, okay, we get a question. There's a question on the chat.
So when you say snapshot, you mean to say server snapshot?
Yes, Pawan, yeah. Server snapshot.
I don't think so. That should work. I think you need to export the entire cluster, and then you need to. We have certain defined scripts for taking a set of procedures. We can look into it, and that's how you need to use it. But, like, just having a server snapshot backup won't work.
So this is with regards to the upgradation of automation suite, right? So when we are actually like planning for upgradation, so it's actually like recommended to take a NFS backup.
Yeah.
So what that was actually like a query whether like server snapshot will be enough or NFS backup has to be taken for the entire cluster.
So when you take NFS backup, right? I hope you are aware it executes certain scripts which is responsible for exporting all the configurations of the cluster from the files. So it exports the entire state of the cluster within the NFS backup. With the snapshot, you won't be able to achieve the same thing.
And on top of
And
that,
you won't be able to get the state, like get the cluster into the same state. So yes, NFS backup is mandatory. So you already have an automation suite cluster running. I think there are multiple ways to approach this. Either you can set up a parallel cluster and then restore the backup, upgrade it, or you can do an in-place upgrade as well. Both the choices are there.
Yeah, but I think for versions, it's side-by-side upgrade is actually like only available with 23.10, I think. So actually, like we had a 22.10, 22.4 version of automation suite. For that, I think there is only one option to upgrade, that is in-place upgrade.
so if I give you the
I think then
details,
what you can do is, right, Yasin, what all applications you are using?
Document understanding, orchestrator, action center, and AI center.
You can set it up as in fresh, directly 25.10 and migrate.
yeah, but key information is that with 25.10, the NFS server for backup is discontinued. You need to use the external storage, external object store.
No, but 22.4, right?
Yes.
22.4. So first you need to hop on to another of the one of the intermediate versions, I believe.
Yeah,
That's the chain.
23.
And yes, so first you will have to upgrade to an intermediate version. I think 23.4,
Okay.
23.10,
10.
and then yeah, 23.10.2 something. Okay, and then you will have to go.
Pavan, you are not audible.
Sorry, am I audible now?
Yeah, you're audible.
Okay, so there are multiple hops to it, and the recommendation would be, how many processes are you having with orchestrator?
So it is around 10 to 15, somewhere in that range.
I think then the ideal scenario would be you can go ahead and just reinstall the 25.10 directly as in parallel upgrade and then migrate everything.
Okay. So
Yeah.
is there any migration tool available, or we will have to migrate everything manually?
I think you can migrate manually as well, and for orchestrator there is migration tool as well. Depending. Or I think Yasin, we can
Yes,
really
yes.
connect on this one.
Sure, go on.
You can drop me a note probably, and then we can have an extended discussion on this one as to how we can take this.
Yes, sure.
There are
Can I
multiple
have?
ways of doing it, but I'm just trying to optimize it for you.
Sure.
Okay.
Yeah, I can. Yeah, I'll drop you an email. Go on.
Okay. Okay. I think Swani, over to you maybe then.
Yes. Thank you for joining, guys. It was an amazing session. See you all in the next session. Even if y'all think y'all cannot attend, register for it. Y'all will get an email with the wrap up. So yes, thank you so much for attending once again.
Thank you guys. Have a great day.
Thanks, everyone.
Thank you.
Bye.
Bye bye.
Bye.
Thank you.
Thank you all.
Thank you.